Hi everyone, this is our CMPEN482 Capstone project where we created a pressure mapping system for a Pectus Carinatum brace, and it is sponsored by Dr. Anthony Tsai from Penn State Health.
So introduction, Pectus Carinatum is a deformity of the chest in which the bone and ribs are pushed outwards. It affects about 1 out of 1,500 children across the globe. In some cases, bracing and union surgery may be necessary. Objective for our project was to improve usability of brace, add electrical components, incorporate Bluetooth compatibility, heat map to show pressure readings, and 3D print all the components.
So our project uses a 3x3 9-pad pressure array, pictures on the left. The goal of our project was to keep the electronics additional to the brace below $150. So the pressure pads add up to around $100. So the rest of the electronics had to cost less than $50. So what we incorporated is a multiplexer and a Raspberry Pi Pico. The multiplexer will take 9 different voltage readings from the pad, separate them into each into their own individual reading, and then send that to the actual data output device. So we used a voltage divider, the multiplexer, combine them together to create a 3x3 array that actively measures the pressure.
All right, so this is the code that's used for our website. What it does is it'll take information, and what you need to input is a password and a username, which currently we have a router that's connecting it. And with the router, it'll output a IP address that we just take and copy into a any sort of Google or any sort of website, and it'll output our data onto the heat map itself.
So to generate the heat map, we are running a web server on the Pi, and we are taking the output pressure values from pressure that's actually applied to the pressure pads, and those pressure values will be visible to the user on the map itself. As we can see here, there's a color scale or a color range in which the values fall, and the color is decided based on the pressure that's actually applied. And it's light blue, light green, yellow, and red. And this is what the heat map actually looks like.
So, conclusion and thoughts. At the end of our project, all of our sponsored goals have been met, which were continuous pressure monitoring system, wireless connectivity, which we performed through Wi-Fi, and maintaining a slim frame of the device. A couple ways that we can improve on the device currently is creating a PCBA print to compress all the wiring down to a more slim factor, and adding a pressure pad array, which would allow us to have more sophisticated pressure readings on the chest.